In this video, we will go over binomial probability distribution, when to use binomial probability. Each trial, there is either a success or failure. So bi means two options essentially. Fixed number of trials. 3, probability of success that is constant, like flipping a coin for each trial, there's a constant outcome. Trials are independent of each other. And the formula for binomial probability distribution is as follows. So if you want, I would suggest copying down this formula because we will solve 3 examples. Flip a dice 5 times. What is the probability that the dice will land on 3 exactly 2 times? The first question that we need to ask ourselves, is this a binomial probability problem? Each trial, success or failure. This is correct because you're flipping a coin. You're either landing on the outcome you want or you're not. It has a fixed number of trials. We said it was 5. The probability success rate is a constant. It's going to be a 50% probability, and trials are independent of each other. If you land on heads the first time, you're not more likely or less likely to land on heads the second time. Trials are independent of each other. If you land on heads the first time, the second time you flip your coin, you're not more likely or less likely to land on heads or tails. So this right here is a binomial probability problem. So now what we need to do is look at the equation. So we said flip a dice 5 times. Let's look at this equation here. N is the number of trials. So N is 5. What is the probability that the dice will land on 3 exactly 2 times? X, the number of success. Exactly 2 times is our number of success. So we see X, put a 2. 2, 2, 2, 2. 2, 2, 2, 2. Next, what is the probability of success? In a dice, there's 6 numbers. So the probability of success is 1 out of 6 to land on 3. So this is 1 out of 6. And finally, Q, complement, probability of failure. There are 5 possible failures. You can land on 1, 2, 4, 5, and 6. So 5, 6. So this right here is our equation. Now if you use a calculator, you would get 625 divided by 3,888, or around 0.16. Now we'll do the second problem. Flip a dice 5 times. What is the probability that at least once you land on 3? Now in this problem, there are a couple ways to look at it. You could think, what is the probability of landing once on 3, twice on 3, 3 times on 3, 4 times on 3, and 5 times on 3. But that would be pretty difficult. But a better way to do this is to find the complement. The chance of never landing on 3 would be a lot easier. So 0 success. So I would say 1 minus 0 success. So 1 minus the number of trials is 5. X, number of success. We're saying that there will be 0 success. We will never land on 3. So we replace X with 0, 0, 0. Probability of success is going to be 1 out of 6. In order to land on a 3, we have a 1 in 6 chance. And Q is the complement, so likewise 5 out of 6. And then we say N minus X. N, number of trials, is 5, minus X, number of success, we're going to say is 0. So simply 5. Doing 1 minus this piece right here, we would get about 0.6. Now we'll do another problem. If you roll a dice, what is the probability that you land on the number 4 at least once? Now you might think it's going to be 1 6 plus 1 6 and get 1/3. Now why is this thinking wrong? So I would pause the video and think about this question. Now the probability that you land on the number 4 at least once will be 11 out of 36, not 1/3. And this is because if you notice, 4 and 4 is a possibility. Now we'll do a third problem. We flip a coin 8 times. What is the probability that no more than 3 are heads? So you can get 0 heads, 1 heads, 2 heads, and 3 heads. And so we need to do 4 probabilities. P0, P1, P2, and P3. Now I did this on a calculator. Essentially I'm doing the binomial probability of 0, binomial probability of 1, binomial probability of 2, and binomial probability of 3. And I would get about 0.36. And that's pretty much it regarding binomial probability distribution.